Hey everybody, Mr. Crabbe here, and I am super excited to take my Verifying Trig Identities mini quiz. I get real pumped for math quizzes. You know what I mean? It's like kind of like the most fun thing I do all day. Yeah, take math quiz. What I'm going to do here is go through the problems in order. Okay, so if you just need help with a certain problem, you can skip around this video. I'm going to go through the problems in order. Okay? All right, I'm verifying identities. I know what I'm thinking right now. It's going to stay, I'm thinking about my formatting. It's going to stay. I'm looking at that first problem, like, my formatting better look like this. Each line, I better keep an equal sign there. I better be changing just one side at a time. Okay. If I'm looking at these two sides, which is more complicated? I don't know. You could do it, you can make an argument for either side being more complicated. I'm going to work on the left side because I see two fractions, and when I think of two fractions, I think, I can put those guys together. I see a common denominator. So I'm going to keep the left side the same. Sorry, I'm going to work on the left side, so I'm going to keep the right side the same. You can literally do this right now. Okay? I'm not touching this side. That is not changing. So I'm just going to rewrite it over and over because it's not changing. Okay? On the left side, what is the thing I'm going to do? Well, I have two fractions. I want to make them one fraction. I need a common denominator. Note that these two fractions denominators are completely different, so the common denominator is going to be those two fractions, or those two denominators multiplied. So I want to make both fractions over cosine times sine. Okay. The left fraction, what I'm doing really is multiplying by sine on the bottom and sine on top. That's going to make the denominator sine cosine, and since I'm multiplying the denominator by sine, I have to multiply the numerator by sine because I cannot multiply a fraction by anything except for 1. That's the only thing that's going to keep it equivalent. Similarly, on the right fraction, multiplied by cosine of theta on the bottom, cosine of theta on the top, that's going to achieve my common denominator of cosine sine. On the top, I'm going to have cosine of theta. Now that I have a common denominator, I can push them together. I have sine plus cosine. I'm right like that. It's fine. Sine of theta plus cosine of theta over cosine of theta, sine of theta. I got a common denominator. I push the fractions together. Last thing is these don't look exactly equivalent. So if I want to be kind of nitpicky, the bottom of the right side is sine cosine, so I can just rewrite those two things in the other order. And the top is written cosine of theta plus sine of theta. So I'm just rewriting things in different orders so that the left side looks exactly like the right side. Okay, and that's it. That's one way to do this. If you worked on the right side instead, you will use the idea of splitting it up into two fractions and making, this into a single fraction and this into a single fraction. And simplifying those fractions. It will look like this. Okay? But I chose to work on the left side, make it look like the right side. Problem number 2. Looking at this, which of these looks more complicated? I think this looks more complicated. So I'm going to work on the right side. I see that 1 minus sine on the bottom. I'm thinking, I can use my conjugate to make that a 1 minus sine squared, so I can use a Pythagorean identity. Okay? That's my thought process. It's not the only way to do this, but that is my thought process. So I'm going to multiply by, 1 plus sine of theta on the bottom. That's the conjugate of the bottom. On the top, I'm going to multiply by the same thing. Okay? If I multiply a fraction denominator by something, I have to multiply a fraction numerator by the same thing. On the top, I'm not going to distribute it out. I want to be really clear about that. When you multiply by the conjugate, the thing that it is the conjugate of, you FOIL that out, you distribute that out, you saran wrap that out in order to get the Pythagorean identity. But the numerator, don't distribute it out. You want it factored, it's going to help you simplify. The bottom, I'm going to use my saran wrap. Saran wrap. And you're going to get 1 minus sine squared on the bottom. You know what I'm doing right now? Write the left side exactly the same. Please, guys, keep the organization there. It is all about organization because this is a justification. This is a proof. It's not a calculation. It's a proof. The work is the problem. Okay? Remember, every time you use the conjugate, the purpose is to get a Pythagorean identity. I have a 1 minus sine squared on the bottom. I'm going to rewrite that as cosine squared. That in itself is a step. Don't skip steps. Skipping steps doesn't show you're smart. It shows incomplete work. That's all it's showing. Okay, don't skip steps. Now looking at the fraction on the right, I got a cosine on the top and a cosine squared on the bottom. Boom! Cosine and the cosine cancel, but since there was a squared on the bottom, I'm just left with one cosine on the bottom. And I'm getting really close. I have 1 plus sine of theta over cosine of theta. Again, I'm writing my left side every single step. It's not changing. Last thing, I can split up this right side into 2 fractions using this idea. Lemke, as we've talked about, calls this monomdenom. Monomdenom. Because you got a monomial in the denominator. Anytime you have 2 things added together in the numerator and you got a single thing in the denominator, you can split it up this way into 2 fractions. 1 over cosine of theta plus sine over cosine of theta. The reason I thought to do that is because I looked at the left side and I said I have 2 completely separate things, so I must split this up. And this last step, I hope, is clear now. 1 over cosine is secant of theta, sine over cosine is tangent of theta. I've now made my right side look exactly like my left side, meaning I am done. Okay. Moving on to problem number 3. This was the most missed problem. Factor the numerator. That's all you need to see. You look at the numerator. It's a quadratic. Obviously, I work on the left side. The numerators are quadratic. If this is looking weird to you, rewrite it in terms of another variable. I recommend some random variable. I'm going to call sine of theta. Oops, sorry, guys. P. Like if you just want to pick a random variable, let's talk about how this factors. 2p squared minus p minus 1 over p minus 1. Okay? I don't want to write this out in the proof like this, but I want to show you the concept here. How do you simplify that? Go back to your Algebra 2 class, your AAA class. You know how to simplify that. Factor the top, factor, and see stuff that cancels out. How do you factor the top? It factors like this. I use guess and check for factoring. If you use another technique, that's fine. You need to make sure you review from your Algebra 1 class how to factor that into that. Okay, that's something you need to know. Once you factor it, what happens is the p minus 1s cross out and you're left with 2p plus 1. Now let's do that with the sines and cosines. Actually, this just sines in this case. So 2 sine squared minus sine minus 1. That's a quadratic expression with sines, so I'm going to factor it. I'm working the left side, so the right side is going to stay exactly the same. Based on what that little work I did, I know it factors to 2 sine plus 1 and sine minus 1. Okay, if I were to distribute that out, I get back to here. Okay. Once you've factored it, once it's factored, things that are the same in the top and the bottom cancel. So that cancels with that, and I'm left with 2 sine of theta plus 1 on the left and 2 sine of theta plus 1 on the right. If you missed that problem, it's likely because you either didn't think to factor or you didn't remember how to factor from Algebra 1 and Algebra 2. So make sure you review how to factor. Okay. Similar for the 4th problem. The left side looks more complicated because it has it to the 4th and to the 4th. I'm going to factor it using difference of 2 squares. Difference of 2 squares is the idea that says x squared minus y squared factors to x plus y, x minus y. Again, this is an Algebra 1, Algebra 2 idea that you need to remember. Okay. In this case, cosecant squared minus cotangent squared factors Right, cosecant to the fourth minus cotangent to the fourth factors to cosecant squared theta minus cotangent squared theta times cosecant squared theta plus cotangent squared theta. Because it's to the fourth and to the fourth, the two things are not like x plus y, x minus y. It's x squared plus y squared, x squared minus y squared. Okay, that's why everything's squared, is because the original problem is to the fourth. Right side, I'm going to keep writing exactly the same. Okay. Now, hopefully you're thinking about your Pythagorean identities because we got a lot of squared trig functions. Cosecant squared minus cotangent squared is 1. You need to know your Pythagorean identities, write them on note cards, memorize them. It's not that many things. It's 11 total identities. A lot of them you already know. Okay. So now I'm left with 1 times cosecant squared plus cotangent squared on the left. On the right, I got cosecant squared plus cotangent squared. Notice that I'm writing an extra step here just to make sure it's extra clear. I replaced the cosecant squared minus cotangent squared with a 1. And now, 1 times cosecant squared plus cotangent squared. That's just cosecant squared plus cotangent squared on the left. And cosecant squared plus cotangent squared on the right. Left side looks like right side. I'm done. Last problem here. I think this was the easiest one, in my opinion. Left side's definitely more complicated. I'm looking at the left side. I'm not going to touch the right side. Again, I want to emphasize, I'm not touching the right side. Some of you guys have been writing stuff like RHS, LH. I don't know what that is. That's not something that I do. I would recommend just writing it out like this. We gave you guys space to do this. Okay. I'm looking at these two terms, and I'm thinking, they're added together and they have something in common. I can take out a greatest common factor. Take out a GCF. What do they both have in common? A cosine of theta. You take that cosine of theta out, you're left with sine squared of theta plus cosine squared of theta. If you don't remember how to take out a GCF, you need to review that from Algebra 1, Algebra 2. Okay. Go to the MRC and ask them about taking out a GCF. Sine squared plus cosine squared. Again, one of our Pythagorean identities. It's 1. So then I have cosine of theta times 1 on the left and just cosine of theta on the right. Last step, cosine of theta times 1 is just cosine of theta. Done. Okay. Those are the 5 problems. I know this is hard and this is new and we're going to practice it more. Keep practicing. That's my advice. That concludes this video. Thanks for watching.